A warm welcome to everyone. In today's session, we'll be going through what do you mean by D2D and what are the challenges that are faced in D2D in 5G technology.
A warm welcome to everyone. In today's session, we'll be going through what are the research challenges that are faced by the D2D. Okay, so earlier in the previous sessions, we did go through across D2D discovery, how the D2D discovery is performed, and what are the user interface that is concerned during the D2D discovery, that is RRC idle state and RRC connected state. And also we did go through about the resource pools that are defined with parameters which include device discovery period, discovery offset indicator, and subframe bitmap. Also, we did go through the mode 1 and mode 2, which are the resource usage communication for the D2D transmitters. And the most important topic which was covered in the previous session was the resource pool for D2D control information transmission and resource pool for D2D data transmission. Okay, and how the D2D communication is performed. And we also saw that D2D communication is based on physical layer broadcast communication for unicast as well as for multicast. Okay, so in this session, we'll be going through the research challenges which the developer is facing, or a developer, or any kind of developer who is facing the challenges in implementing D2D or incorporating D2D technology, that is device to device technology, in the fifth generation. Okay, in earlier generations, in the fourth generation, it was not exploited that much. The D2D technique was not exploited so much. But in 5G, it has been fully exploited, and the major usage of D2D technology will be used in the 5G situations or 5G technology. So we'll go through this, and as the name itself says, it's a research challenge. Okay, so there will be few research questions which will be posed across, and we will be going through what are the solutions which can be obtained for this. Okay, now since 4G LTE D2D, since in 4G LTE D2D communication, the focus is on public safety and potential improvements that can be provided by D2D operation, which was not fully exploited. In the 5G system, such restriction does not exist anymore, and it is predicted that D2D operation will be natively integrated as a part of future 5G system. Okay, so it will be integrated as a future 5G system. Main potential gain that can be achieved includes the capacity through output gain, that is, the after integration of D2D in the 5G system, what are the potential gains that will be achieved? So the potential gain which will be achieved is capacity or through output gain, because the involved devices are in close proximity with potentially better propagation conditions compared to the propagation conditions towards the base station. Link through output can be improved due to, example, better modulation and coding scheme. Okay, that means to say the involved devices are in close proximity. So if it is a D2D, that is device to device communication, both devices should be in a close range. Only then the D2D communication can happen. So both the devices are in the proximity itself, that is near to each other, so which has a better propagation conditions compared to propagation conditions comparing to the propagation conditions towards the base station. So base station will be located somewhere some kilometers away, so the connection between the device and the base station will have many interference, like the weather condition and other many other factors that will be involving. So the capacity or the gain, the capacity or the quality will be more in D2D technology. Okay, and in addition, there is the possibility of sharing the same radio resource among cellular users and D2D users, which can improve the overall spectrum usage. System capacity can be improved due to offloading and local content sharing from the D2D. Okay, which means to say the radio resources which are already available from the base station to the device, from the base station to the device, the same radio station can be used to connecting between the two devices. Okay. Next is latency gain. So, what do you mean by latency gain? The end to end latency may be reduced due to short distance with less propagation delay and no involvement of infrastructure networks entity, resulting in reduced transportation delay and processing delay. That is, latency may be reduced due to a short distance with less propagation delay, because there will be no infrastructure which will be involved here, because it is between a device to device. One device acts as a transmitter, one device acts as a receiver, and same will be the other case. So there will be no much infrastructure which will be available, and as the base station, as I informed you earlier, the base station will be located kilometers away. So there will be no transportation delay also. So the latency gain can be reduced if D2D is integrated in the 5G technology. Next is availability and reliability gain. Okay, D2D can be used to extend network coverage with one hop or multi hop. Network coding and cooperative diversities via D2D can be used to enhance link quality as well. Furthermore, a D2D ad hoc network can be provided a fallback solution in case of failure of the infrastructure, or in the case of infrastructure cannot be easily established. So availability, what is the availability? D2D can be used to extend the network coverage. Okay, it can be used to extend the network coverage where the infrastructure, that means infrastructure here refers to the base station, where the base station is not available, or if there is any failure in the base station, what we can do is we can create an ad hoc network, that is a temporary network of D2D, which can be provided as a fallback solution, okay, for the connection and for the establishment of connection. So as I had explained in the previous class, D2D mainly is used for the safety of the public, and also during the disaster management, during the disasters. Okay, so during the disasters where there will be no subscriber connection, during the disaster where there will be no subscriber connection, so to check or to connect between to the remote areas with the D2D can be used. The same way, D2D, an ad hoc network can be used. So an ad hoc network can be created rather, so that it is a fallback solution in case of a failure of the infrastructure, or in case of the infrastructure is not easily established. So this gives the reliability and this gives the availability of the D2D. Next, enabling new services. By incorporating D2D in the 5G technology, we can enable new services. That is, fully blown D2D has great potential to enable new services and applications not only in the telecommunication area but also in vertical industries. As for example, vehicle to X communication and the extension of D2D solution for vehicle to vehicle communication is a part of LTE release 14. That means to say as V2V, which is mainly vehicle to vehicle transmission, is mainly used in creating an autonomous vehicle. So autonomous vehicle, where vehicle to vehicle, that is one car and another car will be communicating with each other. Okay, so such devices, such techniques, and such new services can be enabled if D2D is incorporated totally in the 5G technology. So these are the gains which we will be obtaining if the D2D is integrated in the 5G technology. That is, the first one is capacity or through output gain, second one is latency gain, third is availability and reliability gain, and fourth is enabling new services. Okay. However, I discussed fully utilizing potential D2D gain poses new challenges also, in terms of what are the new challenges when D2D is integrated with 5G. So the challenges will be: first is device discovery, second is communication mode selection, third is coexistence, fourth is interference management, fifth is efficient multi-hop communication support, and multi-operator support are among the others. So we'll see each and every challenges which are faced by integration of D2D in 5G. Okay, the first one is device discovery. So efficient network assisted D2D discovery, which is used to determine the proximity between devices and the potential to establish a direct D2D link. Okay, this is a key element in order to enable D2D communication, and possibly new applications will be involved. So in the device discovery, what happens is an efficient network assisted device D2D discovery should happen. Okay. So if it has to be efficient, then some technique has to be utilized or used so that the device discovery of the device, that is two devices, should be sure shot. That is, it should be very efficient. So what we can do here is, as we know, D2D is a close proximity connection. It only the connection happens only when the two devices are in close proximity. So what we can do is we can use that as a platform, and you can determine the connection and the discovery. So this is what it is. That's the proximity. Okay, determines the proximity between devices, and potential establishment will be connected when the device is in close proximity. So this device discovery challenge can be overcome. Next one is communication mode selection. The next one is communication mode selection. So in mode selection is another core function that controls whether two devices will communicate with to each other in direct day-to-day mode or in regular cellular mode. So in your cell phone, there will be two modes also, as D2D is integrated in your 5G technology or in your cellular network. Okay, so at any given point of time, which network should be connected, whether it should be connected to the base station or whether it should be connected to another device. So this is what is the communication mode selection. So to overcome this, what we can use, we'll see that in direct D2D mode, the device can take advantage of their proximity and may reuse cellular resources for the direct communication link. In cellular mode, the device communicates through a common or separate serving base station by means of regular cellular links in orthogonal resource with cellular users. How to select the most appropriate communication mode in different scenarios is an important issue which is yet to be solved. Okay. So what happens here is in direct D2D mode, the device can take advantage of their proximity and may reuse the cellular resources for direct communication link. So it's something like your Bluetooth. So Bluetooth has a range of say 10 meters, 10 to 15 meters. Okay. So if any device is within this range, if two devices are within this range, only then the connection will be established. Rest all the time, what happens is the normal cellular mode will be turned on. Same similar to this Bluetooth connection, the communication mode selection can also be obtained. But still, appropriate communication mode in different scenarios is an important issue which is yet to be solved. The next one is coexistence and interference management. So, what do you mean by coexistence? Again, the coexistence is nothing but the existence between the cellular networks as well as the D2D network. Okay, and what are the interference which happens either due to the device to device connection or between the base station and the user interface user equipment UE. What are the interference which happens? Okay, considering coexistence and related interference issue, at least two different aspects should be taken into account. The first one is coexistence among a large number of D2D links, and the second one is coexistence among D2D link and the regular cellular link. As I had already briefed you about this, that is the coexistence among a large number of device to device links only, and also the coexistence among D2D link and the regular cellular link. So this is the coexistence. Now, efficient scheme to handle the interference are of importance in order to achieve the potential D2D benefits. Okay. Next is multi-operator or inter-operator D2D operation. So an inter-operator D2D operation is a clear requirement resulting from V2X communication, resulting from resulting from and supporting resulting from that is from V2X communication and supporting inter-operator D2D operation is essential for the 5G D2D concept. Okay. Without multi-operator D2D support, the applicability of the future D2D solution, that is cooperative intelligence traffic system, will be quite limited. Considering inter-operator D2D operation, issues to be solved includes, for example, spectrum usage and how to control and coordinate user interface or user equipments in D2D communication across multiple operator networks. Okay. So what do you mean by multi-operator or inter-operator D2D operation? Inter-operator D2D operation means it's nothing but inside the cell. Okay. Multi means many cells together. So the cells, everything I'll be showing you in the future slide. Okay. So what are the importance of multi-operator or inter-operator? See, multi-operator, what happens is a D2D device can connect to multiple operators. Okay, so it need not have to connect to only one device. It can connect to many devices. Such example can be used for cooperative intelligence traffic system. Okay, then the second one is the interoperator. Interoperator means only between the two devices. That is V2, V is stagnant. Okay, well, the one device is stagnant, and X can be communicated. X can be connected to any of the devices. Okay, that is V2X communication. So these are the two multi-operator and interoperator D2D concept. Okay. Next, so these are the problems, or these are the issues which can happen when and 5G D2D is integrated in a 5G network. So that is, first is device discovery, second is communication mode selection, third is coexistence and interference management, fourth is multi-operator and inter-operator D2D operation. Okay, so in the next session we'll be seeing through the radio resource management for mobile broadband D2D. Okay, thank you so much.